Alright guys, so today we're going to look at Lesson 6, Session 1, and we're going to be working on pages 109 through 112. So let's take a look at our problem. So we know we're looking at common factors and multiples. So we've learned how to find factors, and we've learned how to find multiples of a whole number. So now we're going to learn how to find the greatest common factor and the least common multiple of two whole numbers. So let's look at our problem. A floor plan for a new house shows a linen closet with an area of 12 square feet, and a clothes closet with an area of 18 square feet. The two closets will share one wall. What are all the possible whole number lengths for the shared wall? So all they're asking, what are all of the ways that we can find 12? What are all of the ways we can make 12? Well, we know we could do 1 foot by 12 foot. We could do 2 foot by 6 foot. We could also do 3 foot by 4 foot. Now we could argue and say that we could do 4 foot by 3 foot or 6 foot by 2 foot, but 12 foot by 1 foot. But all of these are exactly the same as these because of the commutative property. So we're not going to write those. All right, what about all of our factors or all of our ways to make 18? Well, the easiest one, 1 by 18, 2 by 9, or 9 by 2. We could also say 3 by 6 or 6 by 3. All right, now, looking at this section and this section, what is the greatest number that they have in common? So do we have an 18 in common? No. Do we have a 9 in common? No. Do we have a 6 in common? Yes. So our greatest common factor would be 6. But what does that mean to our word problem? So what are all the possible whole number lengths for the shared wall? So we haven't really answered our problem. So we know that the greatest common factor is 6. Well, do they have a 3 in common? Yeah. Do they have a 2 in common? Yeah. Do they have a 1 in common? Yeah. So we could say that the possible lengths are 1 foot, 2 foot, 3 feet, and 6 feet. But our greatest common factor is 6. Just keep that in mind. All right, so now let's look at page 111. So we're going to think about what we know about factors and multiples, and we're going to fill in each box using words, numbers, and pictures. And we're going to show as many ideas as we can. If you can find more, you can write those in your book. So a multiple. What is a multiple? It's the number you get when you multiply a number by a whole number. So what is a multiple? The number you get when you multiply a number by a whole number. What do I know about it? Well, I know that a number is a multiple of each of its factors. What are some examples of a multiple? So 28 is a multiple of 4 and a multiple of 7. Because 7 times 4 equals 28. All right, another example. Let's draw a picture. So here we have 1, 2, 3, 4. Then we have 2 by 4 and we know that equals 8. And then we have a 3 by 4, or 3 times 4, and we know that equals 12. So 4, 8, and 12 are all multiples. So looking at number 2, any multiple of 12 is also a multiple of 4. Explain why this is true. So let's list out multiples of 4. Maybe. So we have 4, 8, 12, 16, 20, 24, 28, 32, 36, 40. All right, what about multiples of 12? So we have 12. Well, there's 1. What about 24? Yep. What about 36? Yep. All right, so we can say that any multiple of 12 will have factors of 4 and 3. A number that has a factor of 4 is a multiple of 4. Well, my pen's not working. There we go. Moving on to number 3. So rectangular paintings hang on the wall of an art gallery. One painting has an area of 24 square feet. Another painting has an area of 32 square feet. The paintings have whole number side lengths and have one pair of side lengths in common. What could the common side length be? So we're looking for factors of 24 and 32. So how can we make 24? Well, I know 1 and 24. What else? So let's see, 1, maybe my pen will write. We have 2 and 12. We have 3 and 8. We have 4 and 6. What about factors of 32? Well, the easy one, we have 1 and 32. We have 2 and 16. We also have 4 and 8. All right, so do we have a 32 in common? No. Do we have a 16 in common? No. Do we have an 8 in common? Yep. Do we have a 4 in common? Yes. Do we have a 2 in common? Yes. Do we have a 1 in common? Yes. But what's the greatest number? So we have 1, 2, 4, and 8. What's the biggest number we have in common? That would be 8. But it could be 1 foot, 2 foot, or 4 or 8 feet are all the common side lengths. All right, and we're not going to worry about part B. All right, and that's the end of pages 109 through 112 for session 1.